Hello everyone and welcome back. So in this video we will discuss the advanced level mathematics, pure mathematics 1 for Cambridge A levels, which is written by Neill and Douglas. So the question number 11 to 22 of this exercise 1A we will discuss in this video. Question number 11 says find the gradients of lines AB and BC where you have given A, B, and C, and check what can you deduce about the point A, B, and C. So the first thing is we need to find out the gradient of these lines. So if we find out the gradient of line by the point A and B, then the formula is y2 minus y1 divided by x2 minus x1. So we call the points of A is x1 and y1, the points of B and x2 and y2. So if you want to find out the gradient of A and B, just substitute the values of x1, x2, y1, y2. So x2 is 7 and sorry, y2 is 6 and y1 is 4. We just substitute that, then x2 is 7 and x1 is 3. 6 minus 4 gives us 2 and 7 minus 3 gives us 4. So we get the gradient of AB is 1 over 2. Now to find out the gradient of B and C, we have to substitute the value of y3 minus y2 and x3 minus x2. So y3 is 1 and y2 is 6, so 1 minus 6. X3 is minus 3 and x2 is 7, so minus 3 minus 7. 1 minus 5, 6 gives us minus 5, and minus 3 minus 7 gives us minus 10. Minus minus cancel, and 5 over 2 is 5 over 10 becomes 1 over 2. So we can see that the lines are the gradient of line AB and BC is the same. This means that the points are collinear. Question number 12. You are given a point Pxy which lies on a straight line which is joined by A and B. So you have a line with A and B, and there is a point, it could be here, the line could be here, P could be here, it could be here, or it could be here. So this is the point that lies on this line. Find the expression for the gradient of AP and BP. So we need to find out the gradients of AB and BP and show that this is given by y is equals to 3x minus 9. So expression of AP is, we have A is 30, P as x and y. So y2 minus y1 divided by x2 minus x1. So y minus 0 divided by x minus 3, that gives us y over x minus 3. The gradient of BP, we have 5 and 6, and P is again x and y. So y2 minus y1 and x2 minus x1. Y2 is y minus y1 is 6, x2 is x minus x1 is 5. So we have these two expressions for AP, the gradient of AP and BP. Now since P lies on that line that is joined by A and B, it means that the gradient of both should be the same. So the gradient of AP is the same as the gradient of BP. We put them equals to, we put an equal sign between them, and then you multiply, we do a cross multiplication, and then expand. So y into x is yx, into minus 5 is minus 5y. This x multiplied to y gives us xy. X multiplied to minus 6 is minus 6x. Minus 3 multiplied to y is minus 3y. And minus 6 and minus 3 gives us 18. Now do the rearranging. Take the y terms onto the left side and x terms to the right side. So this y goes to the right side, becomes positive. This yx goes to the other side, so minus x. You can cancel it for here too. So if you take it to the other side, this is one is positive, one is negative. They cancel out. You are left with minus 6 plus 18. And minus 5y plus 3y gives you minus 2y is equals to minus 6 plus 18. If you divide both sides by minus 2, we get that y is equals to 3x minus 9, which was asked. Question number 13 says that a line joining a vertex of a triangle to the midpoint of the opposite side is called a median. So from the vertex to the midpoint of a line is called median. This is called median. So we need to find out the length of the median AM, where M is the find the length of the median AM in the triangle A, B, and C. So we need to find out AM. It means M should be the midpoint of B and C. If we are asked to find out BM, it means that this median. So M would be the midpoint of A and C. So M is the midpoint of B and C. The midpoint is adding the x-axis divided by 2 and the y coordinates divided by 2. So we have B is 0, 3, C is 4, 7, x1 is 0, x2 is 4, 0 plus 4 divided by 2, y1 is 3 plus y2 is 7 divided by 2, 4 over 2 and that 10 by 2, and that gives us 2 and 5. So M is 5. Now we need to find out the length of AM. So by the distance formula, or the magnitude of the length, we have the x2 minus x1. So we have M, and then we have A, which is given by minus 1 and 1. So AM, 2 minus 1 whole square, y2, which is 5 minus y1 is 1 whole square. So minus minus becomes plus. 2 plus 1 gives us 3, the square of 3. 5 minus 1 is 4 whole square. Square of 3 is 9, square of 4 is 16. If you add them, that's 25. And the square root of 25 is 5. Question number 14 says that a triangle has vertices A, B, and C. Find the coordinates of M. M is the midpoint of AB, and N is the midpoint of AC. And show that by finding the lengths of, by finding the gradients of MN and BC, and say that they are parallel. So the first thing we need to find are the midpoints of AB. We have A, we have B. Just add the x coordinates divided by 2, add the y coordinates divided by 2. So that we get is 1 over 2 minus 3 over 2. Now N is the midpoint of AC. We have A and we have C. So add the midpoint, the x coordinates divided by 2, add the y coordinates and divide them by 2, and we get 3 over 2 comma 4. This can also be written as 1 over 2 comma 4. Now the next thing is need to find out the gradient of Mn. So we have M, we have M, we have N, y2 minus y1, y2 minus y1. So 4 minus minus 3 over 2, x2 minus x1. So 3 over 2 minus 1 over 2. For the LCM, we need to multiply 2 on both sides to make the denominator same. So multiply and divide by 2. We have 8 over 2 plus 3 over 2. We take square root, the 2 common, add the numerators. Similarly, here 2 is in both, so we take 2 common and add the above one, so 3 minus 1. That gives us 11 by 2, and this gives us 1, so that becomes 11 by 2. Now the next thing is the gradient of BC. We have B, point B, and we have C. So y2 is 7 minus y1 is minus 4, x2 is 5 minus x1 is 3. So minus minus becomes plus. So 4 plus 7 plus 4 divided by 5 minus 3 gives us 2. So that is 11 by 2. We can see that they're both same. It means the line MN is parallel to BC. Question number 15 has 3 points A, B, and C of a triangle. So M is the midpoint of AB, N is the midpoint of AC. Again, we have to just find out the lengths. Now we have to find out the lengths MN and BC and show that BC is equals to 2M. So the formula for the first thing we need to find out is the midpoints of AB and BC. M is the midpoint of AB. You know the formula, just substitute the values and we get 2 is M is equals to 2 is 4. N is the midpoint of AC, just substitute the values from A and C and we get the midpoint as minus 1 and 0. Now we need to find out MN, the length between M and M. So M and N, we have M, we have N, just substitute that in the distance formula x2 minus x1 whole square plus y2 minus y1 whole square. Simplify and you get 5. Now find out the lengths of BC. By the formula we have B and we have C, we substitute the values and simplify it and we get that that answer is 10. 10 can be written as 2 times 5 and we already know that 5 is the length of MN, so we can write this as 2MN. So the length of BC is shown to be 2 times MN. Question number 16 says that you are given the 4 vertices of a quadrilateral ABCD and the points P, Q, and R and S are the midpoints of AB, BC, CD, and DA respectively. Find the gradient of each sides of PQRS and what type of quadrilateral it makes. So P is the midpoint of AB. Using the formula, you can find out P easily. Q is the midpoint of BC. Again, midpoint formula, you can find out Q is to be 8 minus 2. R is the midpoint of CD. Using the formula, you can find out that is 3 and minus 5. And S is the midpoint of DA. Using the formula again, you can find out that that is minus 1 and minus 1. The second thing is you have to find out the gradients of PQRS each side of this quadrilateral. So the gradient of PQ is, again, we already know P and Q. Just substitute in the formula y2 minus y1 over x2 minus x1. So we get the gradient is minus 1. The gradient of SR, again using the formula, gives us minus 1. So we can see that the gradient of PQ and SR are both the same and they are minus 1. Now find out the gradient of QR. Using the formula, it gives us 3 over 5. And if you use the formula for gradient of PS, that gives us again 3 over 5. So these two are the same. Since the gradients of the two, PQ is equals to SR and QR is equals to SPS, so this forms a parallelogram. It means that these two sides are parallel and these two sides are parallel, so that gives us a parallelogram. Question number 17 says that you have an origin, which means 0, 0, and then you have points P, Q, and R, forms a quadrilateral with the origin. Show that OR is parallel to PQ and show that OP is parallel to RQ. And then show that the length of OP is equals to OR and then decide which shape is it making. Again, the first thing we have to find is the gradient of OR. We have R, we have O, just put the formula, use the formula, and the gradient is 4. Find out the gradient of PQ. We have P, we have Q. Just put the values and we can see that this is also 4. It means that OR is parallel to PQ. These two straight line means parallel, or you can write down parallel. Now the gradient of OP, again we have O, points of O and P, substitute and we get the value is 1 over 4. And now find out the gradient of RQ, which is again 1 over 4. It means OP is parallel to RQ. Now again they're asking you to find out that the length of OP is equal to OR. So you find out the length of OP We have O, we have P. Using the distance formula and simplify, we get that that distance or the length of OP is square root 17. And similarly, we can find out the length of OR using the points and simplify it. And that also gives us that the length of OR is square root 17. This means that the shape is a rhombus. Question number 18. The origin O again 0, 0. You have L, M, and N, and it forms a quadrilateral. Now you have to show that the length of ON is LM. Then you have to show that the length of ON is the gradient of ON is equals to the gradient of LM. That will tell us that ON is parallel to LM, and then show that the length of OM is equals to the length of LM, and then decide about the shape. So again, the length of ON is, using the formula, give us square root 52. The length of LM is again square root 52. So the part A is that they're both the same, we have shown. Part B, that we have to find out the gradient of ON and the gradient of LM. So using the formula of gradient for ON, the gradient is 2 over 3, and that of the LM is also 2 over 3. So we have shown that in part B, ON is parallel to LM. In part C, we have to show that the length of OM is equal to the length of LN. So again, if we use the points and simplify it, we get that the length of OM is square root 65 and the length of LN is again square root 65. It means they are the same. And now this makes the quadrilateral a rectangle, because if you have an origin O and you have a point L, N, and M, we have shown that ON is parallel to LM, and then also we have shown that the length of OM is the same as the length of LN. So these two lengths are the same, and that is the only case. That is the case in only a rectangle. So that is a rectangle. Question number 19 says that again you are given the vertices of a quadrilateral PQRS and find the gradients of each side of the quadrilateral and what type of quadrilateral that is. So the gradient of PQ is minus 1 over 3. The gradient of SR is minus 1 over 3. They are parallel. So it means PQ is parallel to SR. Now find the gradient of QR, which is 4, and PS, which is 3 over 4, and these are not parallel. So that is making a trapezium, because in trapezium you have two sides parallel sides, and the other two are not parallel. Question number 20 again is a quadrilateral with four vertices, T, U, V, and W. And the midpoint of UV and VW are given as M and N again. So you have to show that the triangle that is made from the midpoints with the point T is an isosceles triangle, which means two of the sides are equal in length. So first we need to find out M, which is the midpoint of U and V. So we get using the formula as 5 and 6. Similarly, you have to find out the midpoint N, which is the midpoint of VW, and using the formula we get that is N is equal to 7 or 704. Now we have to find out the lengths of the triangle TMN. So the length TM, using the M and T values and simplify the distance formula, gives us square root 20 is the length of TM. We find out the length of MN using the formula, gives us square root 8, and the length of NTN is 20. So you can see that two of the sides, the length of two sides TM is equals to the length of TN. That means that the TMN is an isosceles triangle. 21 is that you are given again DF, a quadrilateral, and find out the length of each side of the quadrilateral, and then mention which type of quadrilateral that is depending on these values. So the length of DE when we find out using the formula is square root 10, the length of GF is square root 40, the length of EF is equals to square root 40, and the length of GD is equals to square root 10. And this makes a kite. What does that mean? We can see that D and E, they are both the same. So we have point D towards E and towards G, that these lengths are same, right? And then we have another point which is F, and the distance between GF and EF are the same. And you can see that the kite I have made is, this is smaller, this side which is square root 10, and this is larger, which is square root 40. So you can see that that makes a kite. Number 22, the last one, you are given 3 points of an isosceles triangle. You're given 3 points, and they're asking you that AB. Question number 22. The points A, B, and C form an isosceles triangle with AB and BC of equal length. So the sides AB and BC have the same equal length. The point G is 6, 4. You're given another point G, which is 6, 4. So write down the coordinates of M. M is the midpoint of AC, so we can find out easily the M by using the formula of midpoint. In part B, show that GB is equals to 2 GM, and that GM BGM is a straight line. So what we have to do is find out the length of BG is equals to 2GM. So the length of BG, we have point B, we have G, you can find out the length is 6. When we find out the length of GM, that is 3. So if you multiply the length of GM by 2, it gives us 6. And so that means that BG is equals to 2GM. And next, question part C says that write down the coordinates of N, the midpoints of BC. So we need to find out the midpoint of BC. Again, very simple. Just use the formula and you get the midpoint. And the last part is show that AGN is a straight line and that AG is equals to 2G. So find out the lengths of these ones. AG is 5 and the length of GN is 5 over 2. So if you multiply the length of GN by 2, that gives us 5. So that means the AG is equals to 2GN. To find out that AGN is a straight line, it means that the gradient of AG and that of GN are parallel. 4 minus 1 divided by 6 minus 2 gives us 3 over 4, and the gradient of GN 11 by 2 minus 4 and 8 minus 6. If we simplify this, 2, 11 minus 8 divided by 2, that gives us 3 over 4. So we can see that they are the same. It means that we have shown that AGN is a straight line. Similarly, we can show for part B that it is a straight line. So just find out the gradient of BG. It should be equals to, so the gradient of BG, if that is equals to the gradient of GM, that means that in part B, BGM is a straight line. And I think you can find that.